and welcome. Today we're going to be finishing out SAT practice test number 2, the math no calculator section, by doing the 5 grid response questions from 16 to number 20. If you haven't seen the previous videos covering the rest of the SAT practice test 2, the math sections, please be sure to check those out. And as always, if you like these videos or found them informative, please be sure to like and subscribe. Let's get started. Question number 16. The sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded in amounts of $250 or $750. If at least one $250 bonus and at least one $750 bonus were awarded, what is the possible number of $250 bonuses awarded? Well, since 3,000 is a multiple of 750, we can split the $3,000 bonus into 4 groups of 750. Then we can split between 1 and 3 of these groups into 3 $250 bonuses. So the possible numbers are 3, 6, and 9. Essentially what we've been doing here is we split 3,000 into 4 groups, $750 each, and then we have to have at least one group of 750, so we can't split all 4 of the groups up. And out of the 3, we have to split at least one group up to make some number of 250. So we split those groups up, and we end up with a possible number of 3, 6, or 9, and we split up these groups. And it says they're asking us for one possible number of the number of bonuses awarded for $250. So we can put any one of these 3, 6, or 9. It doesn't really matter. Let's move on. Question number 17. In the equation above, A, B, and C are constants. If the equation is true for all values of x, what is the value of b? Well, we can multiply the left-hand side out to make 6x squared plus 10x plus 9x plus 15 equals 8x squared plus bx plus c. So bx equals the middle part, 10x plus 9x, and that's going to be 10 plus 9, or 19. So b equals 19. Let's keep going. Number 18. The figure above, AE is parallel to CD, and segment AD intersects segment CE at B. What is the length of segment CE? Well, since AE and CD are parallel, and CRD, is at CBD, equals AR here, ABE, can't really see it very well. But since those two angles are equal by vertical angles, the triangles are similar. Then CB equals RD over AR times RE by similar triangles, right? Similar parts of similar triangles are similar. So that would be 5 over 10 times 8, or 4. So then CE equals CB plus BE, which is 8 plus 4, or 12. So even though we screwed up with R and B, right, whichever one that is, it doesn't matter. CE is still equal to 12. 8, we have segments of 8, 4, and our answer is 12. Alright, next one. The XY plane above, O is the center of the circle, and the measure of AOB is pi over the radians. What is the value of A? Well, the y-coordinate is the sine of the radius. Using the Pythagorean theorem, the length of OA is 2, because the square of 3 squared plus 1 squared is 4, the square of 4 is 2. Since the y-coordinate is half the radius, the sine is 0.5, so the inverse sine of 0.5 is 30 degrees, which is 1/6 of 180 degrees. Now 180 degrees is 1 pi radians, so 30 degrees, which is 1/6 of 180 degrees, is 1/6 pi radians, or pi over 6 radians, which means that A is equivalent to 6. Alright, let's move on. This is our last question of this set, the last question of this test, of this section. Let's see what we got. AX plus BY equals 12, and 2x plus 8y equals 60. And systems of equations above, A and B are constants. If the system has infinitely many solutions, what is the value of A over B? Well, if the system has infinitely many solutions, that must mean that AX plus BY equals 12 is simply a multiple or a factor of the second equation. So basically, we multiply the second equation by some number and get the first equation. Now, since we have 12 in the first equation and 6 in the second equation, we're going to multiply by 1/5. That makes, since the first equation is a fifth of the second, A equals 2/5 and B equals 8/5. Then A over B equals 2/5 over 8/5, which is 1/4. So the answer here is 1/4. That concludes these questions, this test. I hope you enjoyed these videos. We are going to be coming back later with another test, practice test number 7 of the SAT. We're going to be doing the same thing, all 58 questions on the math section, but I'll see you then.